Today we're going to talk about call control in Cisco collaboration for enterprise preferred architecture 12.5. Call control is a core element for any communication deployment. It provides endpoint instance registration and call processing. Call control design considerations include like endpoint instance data plan, endpoint addressing scheme, call party presentation, codec selection, PSTN connectivity, general trunking requirements, and other factors. So, initial Cisco Call Manager configuration after installing the Call Manager cluster, we will go follow some basic tests. Is the node name configuration. I'll show you right here. And we have enterprise parameter select settings and the service activation. We have to activate a service and have a service parameter settings. So these settings have all been configured in my lab. However, as an example, we will show you the node name configuration. So you will see this lab has 3 servers in a cluster, 2 call manager pub and sub, and 1 IMP server. So all showing their FQDN. At the first installation, they would either should have shown the host name minus the domain name or IP address. I can change them from this same page by clicking each of the link and modify the fully qualified domain name or IP to change it to IP address. So since it's completed already, so there's no configuration I will have to make. As a structure, the diagram, well-designed diagram is essential to successful deployment of any call control system. The design of enterprise diagram needs to cover 3 main areas. So the endpoint addressing, general numbering plan, and the dialing habits. And we also have to consider routing and CSS class of service. So in this lab, we have San Jose, which ranges 4A555 and 4XXX, this range. And we have RCD range. The RCD range from 972.555. And we have RTP is in 919.555.5XXX range. Now let's talk about endpoint addressing. Let me open a CSS page and partition. Here, the DN CSS holds the all plus E164 directory numbers and other local on-net E164 destinations. For example, a pilot number reaches from the PSTN. All plus the E164 patterns are provisioned as urgent patterns. We'll have to use the DN and directory URI is under partition. The US E164 holds the dialing normalization translation patterns to perform a US specific habitual PSTN dialing. For example, you would dial 91 and 10 digit to a E164. So this can be many countries. You can name it as UK to E164, Italy IT to E164. It needs to be provisioned. So this all host the dialing normalization translation pattern were required to transform the country-specific habitual PSTN dialing to E164. Next, we will find out the US PSTN national. That's a E164 route pattern requires the PSTN access to a national destination in the US. So the other country-specific dialing habits, a country approximately was used the UK PSTN national, a CA PSTN national, depends on your country. So needs to be proficient. Also need to hold the E164 route pattern required to provide PSTN access to national destination of that country. So the reason we differentiate the international PSTN access and the national PSTN access is that we need to be able to build differentiate class of service, allowing the calls to reach national only or national international destinations. So there's PSTN. Another one is the we have the PSTN international. It's easy to require is just for international destinations, and you will see this the B2B URL we created for SIP route patterns required for business to business, the B2B URI dialing through the internet. And last will be the US emergency. It provides access to emergency calls using US specific emergency dialing habits. We'll talk about the partition. After that, so we're going to take a look at the class of service. So the CSS. A CSS is a list of partitions and defines the which partitions and the patterns a calling entity using a CSS can access. So in this lab, we use a dire plan approach and it uses the only line as CSS to define class of a service. In Cisco CVD, Cisco Verified Design List, the classes of service are considered in the list design. You can go to that CVD. So the class of service chosen for the design are only in this example. So if a further class of service are required, then user can be defined equivocally. So you can find in this lab of this is CSS. Very importantly, and next we'll talk about is the transformation and calling party transformation. So let me find these calling partitions. Calling party transformation patterns. Because all directory numbers are provisioned as E164 numbers for calls originating from these E164 directory numbers, calling party information is in E164 format automatically. To simplify and provide a consistent calling party presentation for all possible call flow, all calling party information received from the outside network, such as the PSTN, is normalized to E164 as discussed earlier. When a call is present to a phone or to an outside network, the calling party information presented for that call sometimes needs to be transformed. So it can be transformed to the format expected by the network in case of call being sent to a gateway, or to formats expected by the user in case of call being sent to a phone. So on certain phones, sometimes the E164 is not preferred calling party display formats, even though keeping this information as the E164 simplifies the development and is prefers the format for enterprise development. So in that case, the desired desired format typically depends on both calling and caller entities. For example, we use this partition US phone local. We will transform the calling from PSTN E164 number to show on the phone that you have a calling number showing 919011, and this defines the plus dot explanation that's for phone US phone international. So we added 9011 to dial out the international if you want to call back any missing, if you have any missing calls showing. So you need to assign the calling party transformation pattern to a specific device pool. So let's take a look to the SJC device pool. For example, the SJC phone video, we can scroll down to here, calling party transformation CSS. So it's calling party transformation CSS already assigned there. So we can take a look at each one of them. And you will find out this calling party transformation CSS is assigned to my device pool. Let's go to user, and the user, I'll click find. We find out this user from LDAP synchronization of the call manager with a corporate LDAP directory allows the administrator to provision users easily by just mapping call manager data fields to directory attributes. So critical user data maintained in the LDAP store is copied into appropriate corresponding fields in the call manager database on a scheduled basis. So the corporate LDAP directory remains its status as a central repository. Call manager has an integrated database for storing user data in the web interface within the call manager administration for creating and managing user accounts and the data. For example, the Adam Mackenzie is in the department engineering and lists all information are synchronized from your local LDAP. When LDAP is synchronization is enabled, the local call manager database is still used, and additional local end user accounts can be created also. You can create a user also. So management of end user accounts is then accomplished through the interface of LDAP directory and the call manager administration GUI. Now I'm going to check the user as we have imported for me and from the LDAP. So we're going to navigate to the user management, and end user here is what all you find is synchronized LDAP enabled user. And once I finish checking the LDAP configuration page here, and we'll go to system, the system, and we'll find out this LDAP system. Let's verify the box next to enable LDAP server is checked, and this is not checked on default installation. You will make sure this is checked, and we navigate to next LDAP customer filter, and we click find. Here's the two filters. You will find is remote and local LDAP filters already configured here. So both LDAP filters are extensions of the default LDAP filters for Microsoft Active Directory. Default LDAP filters for other directory types can be found in the SRND of Core Manager 12.x, and this is the filter you can use. The beginning of the phone number as a criteria to determine whether individual user is a local or remote user. So when using a multiple LDAP synchronization agreements, I have to make sure the LDAP filters used by these synchronization agreements are distinct, so that no single user is matched by both filters. So to synchronize all local users to Core Manager, and LDAP synchronization agreement will have to be configured. So the remote and local agreement has already been pre-configured in this lab. To find out, we're going to navigate LDAP and LDAP directory. Here you'll find the local agreement based on the information here. Scroll down and to the LDAP server information, and we will see agreements using LDAP port 636, and it is the TLS enabled. So this is because the security has been already applied to the server. Security is covered in security department, and now is when we would check the platform synchronizing, full synchronizing now. However, this has already done, so I will have to skip this, and I can actually perform the steps if an endpoint I wanted to provision. And here you will see is Cisco Core Manager auto registration information settings. This page creates the endpoints should start auto registering. If my endpoints does not auto register, I recommend a factory reset of all endpoints before connecting to the lab, and we can wipe off all configuration and ensure they are starting like a phone just come out of the box. If I want to continue with the lab guides and come back later to self-provision my phone instead of waiting for all my phones to auto-register, I can also do. So we give it the universal line. I'll give it a universal line template to the auto register phones. IIS confirmation for multicast deployment. When the inter-cluster lookup service, we call here is IIS, is configured on multiple clusters, the IIS updates Core Manager with status of remote clusters in IIS network. The LIS cluster discover service allowed Core Manager to learn about remote clusters without need for administrator to manually configure connections between each other. The LIS cluster discovery service enables the UDS based service directory for Java clients in multi-cluster environment. The IIS is a foundation for global DAO plan replication (GDPR), which allows exchange of reachability information for both alphabetical URIs and number destinations between Core Manager cluster to enable the deterministic intercluster routing for those destinations. So to create an IaaS network of multiple call manager clusters, I needed to assign a unique cluster ID for each call manager cluster in the network, and we're going to activate IaaS on the first IaaS hub cluster in the network, and we're going to activate IaaS on the remaining IaaS clusters in the network. Then we can consider some UDS certificate requirements. In this lab, I have a US cluster and the EMEA cluster. EMEA and US clusters have already been configured for this IaaS and the GDPR. When you may curious what to change this cluster name, so I show you. It takes to your system and system enterprise parameters. Then we'll find out the cluster ID. The cluster ID needs to be configured. In the lab, is pre-configured as US cluster, so we'll keep the setting as it is. Then we'll navigate to advanced features and IaaS configuration. So the EMEA and the US cluster have already been activated for the lab, and then we're going to scroll to the IaaS clusters. Here we configure this as a hub cluster, and we exchange global data plan replication data with a remote cluster. We want to do that, and this is checked, and advertised routing string we use is represent the US route, and so we synchronize every 2 minutes. We use a password instead of the TLS search to synchronize. And here is the cluster ID you will see when it's configured. When the GDPR global data plan replication is enabled across the IaaS network, the remote clusters in an IaaS network share global data plan data, including the directory URIs, E164 and ESN patterns, the PSD and failover numbers. The GDPR allows me to create the global data plan, including intercluster dialing of the directory URIs and alternate numbers that span across the IaaS network. The GDPR allows me to quickly configure the global data plan across the IaaS network without the need to configure each data plan components to own each cluster separately. So we'll configure the GDPR require a few steps in addition to activating IaaS. We have to advertise URIs, advertise the patterns, and configure the partition for learn the number and patterns, and we'll configure the interclass trunk and the SIP route patterns. So advertising URIs is accomplished by default on every URI in each directory number. To prevent individual URIs from being advertised, I could go into directory number and uncheck the box under advertise global via IaaS for URI in the directory URI section. So I will show you. If you don't want to advertise, go to the direct DN, and here you will uncheck this via IaaS. In this lab, all URIs they should be advertised, so there's no anything to be configured. We go to call routing and find the global data plan replication and we'll find the advertised pattern. Click find. So to keep a route plan small on remote clusters in this design, only summary of patterns that are advertised for each E164 and ESN range hosted on each cluster. The patterns for sites like RCD, SJC, and RTP, as well as the EMEA clusters, have already been pre-configured. On the US publisher, these are where we're going to advertise the pattern we have, and go to the learn the patterns. We will learn the number of patterns and we'll give them the partition on that remote. Check one of them. This one we learned. And the route string is emea.route. Let's navigate to car routing and SIP route pattern. And I'll click find. The SIP route patterns that tie together SIP route string learned via GDPR and a SIP trunk topology. Think of this as if a GDPR route string tells us where a learned URI or numeric patterns located, and we need route pattern matching on these route strings to tell how to get this destination. So to achieve full GDPR reachability, we need to make sure each SIP route strings advertised via GDPR can be routed according to provisioned SIP route pattern. And we have a route to EMEA routes. As using SIP trunk and route list. Let's take a look at this route list. This is my inter-cluster trunk. So actually it's not include any route group. We have to find that route group and assign to here, and it's in the route group. It's the UCM EMEA route group, and it has a SIP trunk to use call manager EMEA. Let's take a look at this trunk. This is a trunk described as I intercluster trunk to EMEA cluster, and this is my European call manager. Alright, so the GDPR exchange only makes sure that all URI and numeric reachability information is exchanged between the call manager clusters and associated with the SIP route string as local attribute. The sessions between clusters need a SIP trunk to be established. So in this design, we're assuming full mesh trunks between all call manager clusters with a maximum of 3 call manager clusters. So the maximum of the 3 call manager clusters make sure that topology of a full mesh of the SIP trunks is manageable. If more than 3 call manager clusters are required, then adding a call manager session management addition SME is recommended to simplify the topology to a hub and spoke topology with SME as a hub and all other. This diagram show you right now. SME is here to actually simplify the topology to a hub and spoke as husband and all other call managers as spokes or the leaf clusters. Take a look at this. If the call dials to UK, then your San Jose call manager find out the string is taking you to london.uk.eu matching an existing SIP route pattern I showed you, and it goes to trunk to my SME. The SME has a record or repeat at GDPR lookup and will route the call to the London UK.EU over a route pattern SIP trunk to this London cluster, and is all routed by the SIP trunks.
Hey everyone, NetMaven here. Don't forget to hit that subscribe button to dive into the world of amazing network technologies with me, and please feel free to leave your comments below. Hey everyone, NetMaven here. Don't forget to hit that subscribe button to dive into the world of amazing network technologies with me, and please feel free to leave your comments below.